Everyone. Okay, so another day, another Leetcode problem. So today we're going to be solving 2615 sum of distances. So let's just go through the problem. You're given a zero indexed integer array nums, and there exists an answer array of length nums of length where array of I is the sum of the absolute difference between I and j over all j such that nums of j and nums of I are equal and j is not equal to I. And if there's no such j, then you just have to keep that value as 0. And you have to return this answer. So yeah, I'm just gonna go directly and kind of show this out. And let's see over here. So what they're trying to ask us is for, let's say for the index value of 0 over here, I have my number here is 1. So I want to look for other values of j where the number is actually 1. So I see for index I is equal to 0, I have j values equal to 2 and 3. And then we want to take a summation of the absolute difference between these index values of I and j. So what I'm going to get over here is 2 minus 0 plus 3 minus 0, which is equal to 5. And that's actually the answer I have over here. And if we look at 3, for index value is equal to 1, we don't see that there's any occurrence of 3 that happens after that. So by default, we have a value of 0 here. And if we take another example, let's probably take index I is equal to 2. And then we see the other values of j where 1 is actually occurring again are 0 and 3. So we get here is, we get 2 minus 0 plus 2 minus 3, absolute value of that, which is going to be equal to, it's 2 plus 1, which is 3. And then we have a 3 over here. So yeah, basically the question is pretty straightforward. I'm just going to go ahead and write the brute force code because that it's honestly it doesn't really require any thinking here. So let's just write that out, and I think it's pretty understandable on its own. So let's just go ahead and take n length of nums. Then we want an answer array. Let's just default that to 0 because that's the default return value as well if nothing works out. So let's go ahead for I in range n. Since we want the sum, let's go ahead and take current sum 0. Let's iterate through j for j in range n again. I want to make sure that I and j are not equal. So if j equals I, let's just continue this. Anyhow, we have a value of 0 there. And now if it's not, we want to check if the values are the same. So if nums of I is equal to nums of j, let's go ahead and add this to our current sum. So we can do current sum plus is equal to the absolute value of I minus j. And after checking all values of j, we should have our answer. This should be an answer of I is equal to current sum. So if I go ahead and return answer, I should be getting a correct value. Okay, so let's just see, this is the brute force approach. We don't have to submit it because this is going to give a time limit exceeded. So as we can see, the time complexity here, we're just running two loops. So it's going to be O of n square. And the space complexity is O of n, which is actually for the output answer array. So we don't really need to consider that. So yeah, the question is, how can we optimize this? And I'll just get to that. First, I'm going to take another example, a different example that I've written out here, because I think it'll help me explain the intuition more. And we'll see from here. So what I see that I'm doing is that for each value, I'm looking for all the other index values that have the same value again in nums of that index. So I see that even if I do it for index 0, and I look for all the ones that are in different index values of j, I do that. And then again, for this one, I'm going to do that again. So I see that there is a lot of repeated redundant work that's being done. And what we're actually utilizing is the index values. So my brain is telling me that why not just kind of keep these index values handy so we can utilize that instead of running through the whole array over and over again. So yeah, let's say we cache those values into like, let's say we have a hash map that maps the number against all the index values there. So yeah, let's see if we have that, how can we work with that? Probably let's take something like a position map that's going to map the value of 1 to all the index values that it's present at. So if I look at 1, we have it here. Okay, so yeah, I think that's it. So we have 0, 2, 4, 5, 6, 7, and 11. Yeah, I think I got all of them. Okay, so now let's see. Let's probably take some example in this one of the ones here. So we index 4, so that corresponds to this one. And I want to see what answer of index 4 would have to be, right? So if I want to look for the answer of that, I know that it's obviously the values of j and I and the absolute value between those differences. So if I stand here at this position and I look at it, what I'm going to get is actually, it's going to be this index. This is the ith index, right? So it's going to be 4 minus 0, because that's where the first one occurs, plus 4 minus 2. And then once we go to the right side, it's going to be those values, j minus I, absolute value again. So we're going to get 5 minus 4 plus 6 minus 4, 7 minus 4, and 11 minus 4. All right. So that's eventually what's going to give us our total answer of the summation of these absolute value differences between those indexes. That's going to be stored in answer. So let's see if I observe this. I actually kind of see a pattern over here. I see that we are accessing values to the left, and then we're accessing values to the right. And if I go ahead and actually look at what those values to the left are and what those values to the right are, I see that every time I'm repeating this number 4 and I'm subtracting the previous index values. So does that kind of show us something here, that it's a certain number of 4s subtracting the sum of all of the values that had come before this? And yes, that's correct. So if I go here and actually, this is getting a little messy, but if I go and write these index values here, and then we have the size of this, which is 7, then let's see how I can utilize that. So if I look at the left side over here, I can see that the left side, we have 2 4s that are being multiplied, which is basically the index value here. So I can take that as I times whatever was in position map of that index. So let's say that was positions. So positions of I would correspond to this index, the value stored in that certain index. So that would be 4. That would be giving us 4 times 2 over here. And from this, we are actually subtracting these values, 0 and 2, the sum of 0 and 2, because this can be written as 4 plus 4 minus 0 minus 2. So if I'm actually talking about the sum of the values before it, then this kind of tells me that I can have a prefix of values. So that's actually the core behind this whole problem here, is that we are going to be using prefix values for each index here. So if I take a prefix sum up to the index 4, then I have that prefix sum. So I just subtract prefixes of my particular index value. So I'd be having a sum of 2 over there. So this gives me my left side, and then I want to add the right side, right? So if I look at the right side, I am taking a sum of all the values that come after 4. So it's these values, these 4 values, the summation of all those values. So I can actually get that by, I'm assuming you guys know prefix sums. I'll write that out later. But if I take the prefixes of the last value, which basically has every value's sum before it, so that would be prefixes of m, and I want it up till here. I want all these values. So prefixes of m minus prefixes of I plus 1. from that sum, we see that we're taking the value of 4 again and again. So we're going to be subtracting 4. So 4 is basically at positions of I times this difference here. So that difference is actually, what is it? It's the size. It's 7 minus wherever index 2 is. 7 minus 2 is 5. And then we have off by 1. So it's times m minus I minus another 1. So yeah, if we do this, we actually get whatever we have to store in answer. So let's just take an example in case you don't know what a prefix sum like actually is here. So I would have prefixes storing values of 0 by default. So initially it would be 0, then I'd have all these values to fill. And what happens at index 2 is I'm going to add everything, sorry, not at index 2, at index 1 is I'm going to add everything, the prefixes before it, and the number over here. So I would be getting 0 again. And for this value over here, 2, before 2 we have 2 and 0, so the prefixes of 0. Sorry, the number before it, which was 0, plus the actual index value that was there. So we'd be getting a value of 2. And once I come here, again, I'd be adding 4. So we would have 6, which would be the prefixes of the number 5, and so on. So yeah, I'm assuming you guys know prefix sums. So let's just go ahead and probably jump to the code. I think that's it's much more understandable when we do that. So one thing that we can see is because we are doing this pre-computation of work and actually calculating this prefix sums, we're not repeating it again and again. So in total, we would be doing this for all the possible index values, which is basically n. So that computation happens in n, and we're not doing it in n squared. So yeah, let me write out the code and I'll just tell you about the time complexity over there. So we have n is length of nums, and we discussed that we want to pre-compute stuff. So let's have a position map over here, which is going to be a default dictionary of list. Let's go ahead and pre-compute index values for all numbers. Okay, so let's just go ahead for I, number n, enumerate of nums. I'm going to go ahead and add position map of that number. I'm going to append that index. Okay. By the end of that, I have all the index values corresponding to those numbers. Let's go ahead and take our answer. So answer will be 0 times n. So now what I talked about was we're actually dealing with those index values themselves, not the actual number here. So we get those index values grouped by each number in position maps. So if I do for, so I'll show you here. What I was showing here is position map of 1 is this. So this whole thing, I'm going to consider this as something called positions, and we can iterate through that and do this calculation. So let's do for positions in position map dot values. Okay, so I see that there was a certain size to that, so I'm just going to go ahead and take the length of positions for that. And now what we talked about was the next step was that we were gonna construct a prefix map for it, right? So let's say prefixes is equal to 0 times m plus 1. This is m plus 1 because everything stores values before it. So the last m value will have the sum of all of the values that were in positions. Okay, so let's go ahead and populate this for I in range m. We want to do prefixes of I plus 1 as equal to prefixes of I plus positions of I. Okay, so that gets updated to the next value. So yeah, after this we have all our prefixes, and now for each index value that was there, we want to use the pre-computed prefix sum values here to actually calculate the value of what answer is going to be for that. So again, we're going to do for I in range m. What did we have? We had a left side, we had a right side, and then we had our answer, for that specific index. And that index, as you can see, was actually this value. This value is the index of answer that we're going to populate. So it's going to be answer of positions of I is going to be left plus right. And yeah, after this, I'm just going to return my answer. It should be populated. So now let's talk about left, as we had seen this before. So left was basically this here. So it's going to be I times positions of I, and we're going to subtract all the prefix, the sum of the prefixes that came before it. So that is basically stored in prefixes of I itself. So that's our left component. And our right component was basically the summation of everything to the right of it. So we were getting that from prefixes of M minus prefixes of I plus 1. And from this, we were subtracting that certain, we were subtracting 4 times the position of I itself. So that's going to be positions of I times M minus I minus 1. Okay, so this should work. I hope it does, and yes, it does. So let's just go ahead and submit it, and it works fine. So let's talk about the time complexity of this. It looks like we're using loops, but actually we're just, we are doing it in O of n time. So if we see here, this pre-computation took us an O of n time, and we are iterating through all of these positions in position map values. So we are not going to have 2 index values again for another number, because that's not possible. So the total that can happen here is all of these position values together would actually, like, the number of iterations that would happen would be at max n, because that's the number of unique elements that can be possible. So this would happen in O of n. And what we do over here, this is only done once per index. So every time we have a certain value, all the index values corresponding to that index just get taken care of. So it's not done repeatedly over and over again. So in total, this is also done in O of n times. So this is in total actually supposed to be O of 3n, which is basically O of n. And we have our space over here, and even the space that's taken is it's for the total value of index values that are actually possible. So again, that's going to be O of n, and if we consider our output, that's another O of n, but I'm not going to consider that. So yeah, we have time of O of n and space of O of n, and this is the optimal approach for this. So this is using a prefix sum approach. And yeah, I hope you guys understood this, and if you have any doubts, just mention it in the comment section, and I would really love feedback. So yeah, thank you and happy coding.